I will say this question at first does look intimidating, but notice how these two numbers are so close together. We could distribute. We'd be looking at the antiderivative of 25th roots of x, just like the square root of x or the cube root of x. Take away x times the 5th root of x. Well, this helps more than what I was drawing earlier. Now then, that's the same as 20x to the understood 1/5. Take away x really close to x to the 1/5. If they're really close, they are multiplied. And when we have matching bases multiplied, our job is to add the exponents. We don't see an exponent here, but it's understood to be 1. So we've got 1 and 1/5, or we could call it 5/5 plus 1/5, which is 6/5. Okay, making a mess. You just can't see it. Okay, well now I'm ready to go ahead with that indefinite integral. We will add 1 to the powers and divide by that number. When we do, well, that's 1/5 plus 1. 1/5 plus 1 is the same as 1/5 plus 5/5, which of course is going to give us 6/5, and we'll divide by that. Take away, that's x to the 6/5. When we add 1, that's the same as 5/5, just like 2/2 and 3/3. Divide by that same number, 6/5 plus 5/5, and of course the constant of integration. This is 20x to the 6/5 divided by 6/5, x to the 11/5 divided by 11/5. But we know when we divide by a fraction, that means multiply by the reciprocal. So that would be 5/6 times 20x to the 6/5. Take away from that 5/11 times x to the 11/5 and a constant of integration. So let's see, 5 times 20 is 100, but we're going to divide by 6. And 100 divided by 6, we could reduce that. We could call that 50 divided by 3. If we cancel a common factor of 2, x to the 6/5, take away 5/11, x to the 11/5 plus c. Not as hard as I thought.